Hi everyone, Queeveen here from the comfort of my kitchen. In today's video, we are going to look ahead to the end of August to see a lunar eclipse. But first, tomorrow is the solar eclipse that I have been talking about at least all year. Here in Ireland, we will get to see a 97% total solar eclipse. If you are on the edge of Ireland, down in Kerry, for example, here in Cork City, we will see 96.4% of a total eclipse, which is quite a lot. Other areas in Europe will mostly see less. Unless you're in Spain, Iceland, or Portugal, you're going to see less than this. Of course, Greenland as well will get a 100% total solar eclipse, and we can see Venus there during the day. Very quickly, of course, tomorrow is the solar eclipse. Tomorrow is also the peak of the Perseid meteor shower. And when I say tomorrow, really I mean after midnight tomorrow into the next day, but I think it's easier to just say go out on the 12th and wait until after midnight, so we can see here quite high rates from this meteor shower. If you would like to learn more about the solar eclipse and this meteor shower before they happen, check out some of the previous videos on this channel, because in this video, as I mentioned, we're checking out the lunar eclipse that's coming up on the 28th. So here we go. We're looking at the sky here quite late, well after midnight. So the moon is pretty high in the sky. We'll take a look at the moon here just as it's rising. We're back on the 27th, so we're up to 99.9%. And if we move forward to the 28th, it goes down to 99.5%. So that means sunset on the 27th is closer to the full moon for us, even though we're only seeing 99.9% here. If we move forward, hopefully that will go up to 100% over the course of the night, because of course, here we go, the moon has to be 100% full directly behind the Earth to enter into our shadow and give us a lunar eclipse. In this case, it is partial. Firstly, we can see the Earth's penumbra, the very edges of our shadow crossing onto the moon, and then our actual shadow. Of course, this is a partial eclipse, so as we can see here, the entirety of the moon is not being covered. Even though the Earth's shadow is much larger than the moon, in this instance, the moon isn't close enough to the center of our shadow. Our shadow is so big that the moon doesn't even have to cross the exact center of our shadow to produce a total eclipse of the moon. As long as the moon is totally occluded by the Earth's shadow, it is a total lunar eclipse. But this is the best we're getting here. So we're seeing that the moon isn't completely dark. There is a little bit of brightness sticking out the side. I wonder if there is a degree of obscuration being given that this is an eclipse. There doesn't seem to be, but as we can see, it is quite a lot of the moon in our shadow. The Earth's shadow isn't completely dark because some of the sun's light is able to pass through our atmosphere, and after being refracted and diffused by our atmosphere, only red wavelengths are left to impact the surface of the moon. But we can see a little bit of a bluish grey shadow here on the edge. That's some of the sun's light being diffracted by the edges of our upper atmosphere and the ozone layer, rather than being diffracted by the majority of our atmosphere, the oxygen-nitrogen mix that we have down here on the surface. This more diffuse area of the Earth's atmosphere, well, this shadow produced by a more diffuse area of the Earth's atmosphere does look a little bit different. But that is the true shadow of the Earth. There is a partial shadow of the Earth which is covering the moon here. It is difficult to see. We'll take a slightly closer look. As we move now back in time, the moon gets brighter. So there is a difference between the moon here, completely unobscured. If we move forward, the penumbra moves onto the moon. So this is a partial obscuration of the moon. We can see a little bit of the Earth's true shadow there, but the moon is darker in this partially obscured state than in the fully unobscured state, and here we are coming up to the true lunar eclipse. So it looks like we're getting about the peak of this partial lunar eclipse just as we come up to 5 o'clock in the morning, so that's when the eclipse will look best. A good portion of the moon is covered, even here at 4:30 in the morning. The beginning of the eclipse proper The Earth's actual shadow moving onto the moon is just about here at 3:30, and the penumbra of the Earth is sliding onto the moon, again moving backwards here to the beginning at just about 2:20. So this eclipse for us is happening very, very close to morning time. There will be locations on Earth where this eclipse is happening closer to midnight, and of course it is going to look a little bit better from those locations. So the moon is setting for us and the sun is rising just as the eclipse reaches its maximum. And the moon setting, we can see a little bit of darkening happening to the moon there as we move closer to that point about 5 o'clock in the morning when it's obscured. But we can see that obscuration is happening over towards the west. So westwards is where we need to go. So we will hop over the Atlantic simply because not many people will be viewing this from the center of the Atlantic. So we'll jump over here towards the Great Lakes, the edge of the Great Lakes, the eastern edge of the Great Lakes, closer to Ireland. And we'll take a look at how obscured the moon is here. Brilliant. This is the moon getting fully obscured by the Earth's shadow at just about 11:30, 11:10. Let's move back here a little and see where it really peaks. Just about here, at just before 11 o'clock, it still seems to be increasing just a little bit. You might be able to see, and there I think it began to decrease. It did. So we'll move back just a little bit, and I think that's the peak at just about 11 o'clock, not quite 11:10. And there is the moon, about as obscured as it's going to get, and we're seeing it so close to midnight. And here we are, pretty close to the local midnight in this area. The moon is almost directly above the south. I think it may improve just a little bit more if we move even a little further. No, not to the west. It would improve if we moved a little further east, so just into the Atlantic off the coast of North America. Perhaps the island of Bermuda. In fact, if we move a little bit lower, nope, Bermuda is not coming up, but around Bermuda, one corner of the Bermuda Triangle, it looks like the moon is at its highest in the sky at just about the right time. So here we are, we're just minutes past midnight here, almost at 1 o'clock, and we're seeing the moon there pretty much as obscured as it's going to get. If we move a little lower on the planet, we can see there's a little bit of wobbling here, but the amount of the eclipse isn't increasing. We've now moved into the southern hemisphere, so things appear upside down compared to what we're used to here in the north, but the amount of the eclipse isn't increasing. It is still quite a lot of an eclipse. There is still a good portion of the moon covered by the eclipse here. As we move further and further east, we can see it happening earlier and earlier. So we're here at just about 8:20. 8:20 pretty much in California, and we're seeing the eclipse at its maximum. Whereas if we come back towards Ireland again, it's about 4 o'clock, 10 to 4 here in the morning once we're back here to Ireland. So of course, it is very different times from different locations around the Earth, but we can see that the degree of eclipse is pretty much staying the same. We moved too far down there and the moon set, but we can see from large portions of the Earth, well, at least from Europe, perhaps not the best part of the eclipse, we can see that it is of course getting very close to morning time, even as we move a little bit into Eastern Europe there. But all along Western Europe, all along Africa, all along the Americas, certainly there for North America, and down here for South America as well, all of South America, this lunar eclipse is going to be visible. It looks like it might be just out of view once we wrap around to the other side of the Pacific, and even from the center of the Pacific, it is underground. But that is the lunar eclipse that is paired with the solar eclipse that we are getting this week. So we'll zoom out, we'll get rid of the atmosphere, the ground, and we will bring up the line of the ecliptic. The ecliptic line is really an imaginary line in the sky. It's not imaginary per se, that's the ecliptic grid, here's the ecliptic line. It's not so much that it's imaginary as that it is created by people. This is a man-made line in the sky, but it's based off where the sun's equator would be projected out into space. So looking along the ecliptic, we have Saturn, we have Uranus, we have Mars, we have Jupiter, we have Mercury, and we have Venus, all pretty close to this line. Of course, we have the sun, and then back over here we have the moon. So the moon and the sun are on exact opposite sides of this line here. So here we can see the moon and the sun together. The moon is on the ecliptic, which means it is directly opposite the sun here. It is in our shadow. The moon can cross the ecliptic at other times, but if it's a full moon, it needs to be directly behind the Earth. As we move through time here, moving back to the solar eclipse, we can see that the moon goes below the ecliptic. It doesn't stay on it because the moon is following our equator rather than the sun's. But once we come up to the day of the eclipse, of course, we're in the middle of the night, so we're not at the time of the eclipse, but we can see the moon moving back onto the ecliptic just there. So this is the moon's path across the sky. As the moon moves across the sky, it will move across the ecliptic, but it does not follow the ecliptic as the sun does across the sky and throughout the year. So we can see the moon here coming onto the ecliptic to cross onto the face of the sun. And if we move back, we will have to move fairly quickly, but we can see the moon is pretty far from the ecliptic here as it wobbles through its phases and then comes back up to the ecliptic to move into our shadow, more or less at least. So let's move back to catch that happening, because it will be just as the moon crosses the ecliptic. There we go, and there is the moon in our shadow. Now, of course, this isn't a perfect eclipse. If the moon was crossing the ecliptic just a little bit further along, it would be a total eclipse. But because this cycle isn't perfect, here the moon is going to land a little bit off our shadow. When it comes back around to full next month, it will be a little off the sun and it won't cause an eclipse. And it will progress, it will move its crossing points along the ecliptic as it moves, as we move, until eventually it all lines up again. And for the solar eclipse, that's going to be in August 2027 in Spain and North Africa. But there we go. We have this lunar eclipse coming up at the end of the month. And tomorrow, of course, we have the solar eclipse. So I hope you get to see both of them and the Perseid meteor shower. And I hope that you enjoyed this video. If you did, please subscribe to this YouTube channel. And you can read this information on my website, queevinscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.